Hey there, geometry. Thanks so much for tuning in with another episode of Math with Mullins. Today, our lesson is going to be over 1.4, the perimeter and area in the coordinate plane. We want to make sure that we can classify polygons first, but then we also want to make sure that we can find perimeters and areas of those polygons in the coordinate plane. The first thing we're going to fill in on our notes are just our different vocabulary terms. Polygon is a closed figure formed by 3 or more line segments called sides. That's our very first line we're going to fill in. Each side intersects exactly 2 sides, one at each vertex. That's what you're really when you make a point. Okay. When we name a polygon, it's usually by listing their vertices in consecutive order. So that means usually it means like ABC order. Or when you're trying to compare 2 or more polygons, that is when you're going to match up the first letter of this polygon matches with the first letter of the other congruent polygon. Okay. If needed, pause here, make sure you have all your notes filled in, and when you're ready, click play to go on. A few other ways we want to classify polygons is of their sides. We have 3 sides, a triangle, 4 sides, quadrilateral, and then we continue to go down the list all the way down to 12 sides. If in sides just represents whatever that number is gone. So if we have 13 sides, because it's more than 12, it'd be 13 gone or whatever. So essentially you're just adding GON at the very end. I think that's right. And then the other thing we want to cover is what is the difference between convex and concave. Convex is when no line contains a side of the polygon going inside the polygon, but a concave is when you have a side of the polygon going in. So like this is concave because we have the polygon kind of like folding in, whereas convex, all the sides are on the outer perimeter of that. We're going to do right here, you're going to pause this video, you're going to decide what should we classify the polygon as, and then we will tell if it's convex or concave. So number 1 is going to be a pentagon because it has 5 sides. And this is a concave. You can think about like it's making a cave right here because it's going inside the polygon. Number two is a heptagon. So if you counted those sides, 1, 2, 3, 4, 5, 6, 7. And this one is convex because it's not concave. The next we want to make sure we understand is how to find perimeter or area of given coordinates. Usually you'll be given a piece of graph paper, but if you're not, we want to make sure we're following these steps. First thing we want to do is sketch a picture of it. And then 2 is we will use that distance formula, which we learned a few lessons back. If you need to go back and review that, you can. That is what we will do to find the lengths of each side. Here in this box, we have just reviews of perimeter and area. Remember, perimeters, we're just adding all the exterior sides. For the triangle, the square, and the rectangle, those are the 3 main shapes we'll see today. But area is found a little bit differently. Triangle is 1/2 base times height, or you can do base times height divided by 2. Squares and rectangles, we're just doing base times height and finding our area that way. Let's continue on and start to look at some of these. Now, these are when you're going to want to use your distance formula, which is represented here. You have the square root of the differences of your x values plus the difference in your y values. And you also want to square them. That was one thing I was forgetting. So the differences in your x values squared added to the differences in your y values squared. And this should be a subtraction. So I'm going to fix that. And what I would like for you to do is go ahead and try your first 3 examples with your papers. So right here we have number 3 of find the perimeter of the polygon with the given vertices. How you can do that is find the distance of DE, the distance of EF, and then the distance of DF. Okay, and that connects all sides. So let's go ahead and take time now to pause the video here. Try finding the distances of those 3 segments, and when you're ready to check, click play. All right, so the first thing I'm going to do is I'm going to focus on DE. DE, I'm going to have, and I'm going to label these as my x1, y1, x2, y2. So the very first thing I'm going to do is find the differences in my x values. So that's 4 minus negative 3 squared plus 2 minus 2 squared for my y values. Okay, that is going to give me 7 squared plus 0 squared, which would give me the square root of 49, because 7 squared is 49, which means that distance is 7. The next one we're going to try to find is EF. So again, I'm going to change this to maybe make my E's x1, y1, and my F's x2, y2. So I'll find the square root of x2 minus x1. That is going to be 4 minus 4 squared plus y2 minus y1, negative 3 minus 2 squared. Okay, that will simplify to be 0 squared plus 5 squared, which ends up being just 25, and the square root of 25 is 5. Last but not least, I have segment DF, and again, I'll use x1, y1 as the same for point D, and then point F will be x2, y2. So finding the differences in my x values, x2, which would be 4, minus negative 3 x1 squared, plus y2, negative 3 minus 2 squared. Okay, 4 minus negative 3 is actually 4 plus 3, and that's going to be 7 squared. And then negative 3 minus 2, that's negative 5 squared. Okay, which is going to end up being 49 plus 25. That's going to give me the square root of 74. This is where we're going to have that decimal, so we're going to round it to the 10th place value, which is about 8.6. I'm going to actually do about 8.6. Okay, to find the perimeter, all we have to do is now add all three of these things. So 7 plus 5 plus 8.6 would give me 20.6. We'll call this units. Okay. Scrolling on down, we're going to try number 4, and then we'll go on to some area questions. So for number 4, we want to make sure we can find what's the distance of GH, what's the distance of HJ, and what is the distance of GJ. So again, we can pause the video now, take time to try this on your own, and when you're ready to check, click play. All right, GH, I'm going to label these, let's do green, we'll do x1, y1, x2, y2 for H. So we find the differences of our x2 minus x1. So that's 2 minus negative 3 squared plus 2 minus 2 squared for my y's. That will translate to 5 squared plus 0 squared, which ends up being the square root of 25 equals 5 for that first length. For HJ, I'm going to reflect and say that H's are now going to change to my x1, y1. J's will be my x2, y2's. So I'm going to do x2 minus x1, that's negative 1 minus 2 squared for J to H, plus negative 3 minus 2 for my y squareds. Okay. Negative 1 minus 2, that's going to give me a negative 3. So negative 3 squared plus negative 3 minus 2 is negative 5 squared. Okay, that is going to translate to 9 plus 25. So I'm going to end up getting the square root of 34. This is not a perfect square, so we are going to round it. We can round this one to about 5.83. We'll stop right there. And then GJ, again, we'll do G x1, y1, J x2, y2. So x2, y2 would be negative 1 minus negative 3 squared plus negative 3 minus 2 squared for my y2 minus y1. Negative 1 minus negative 3, that actually means negative 1 plus 3. So that would be a 2 squared plus Negative 3 minus 2, negative 3 plus negative 2, that's negative 5 squared. That's going to translate to 4 plus 25. So we're going to get the square root of 29, and that's going to translate to about 5.39. So to find our perimeter for number 4, we'll take 5 plus 5.83 plus 5.39, and that's going to give us about 16.22 units. Okay, that'll conclude our perimeter section. Now let's try some with area. So this next question I did skip 5 and 6, but 5 and 6 still talked about perimeter. Just for the sake of time, we're going to talk about 2 questions on area. For this one, it says find the area of the polygon with the given vertices. Notice how you're not given a coordinate plane. So what we're going to do is go ahead and draw one for ourselves, and we're going to go ahead and plot these points on a hand-drawn coordinate plane. All right, so here I have G at 2, 2. I have H at 3, -1, and then I have J at -2, -1. I am going to go ahead and connect these points so we can see our triangle take shape. Okay. Then we need to find area. Remember, area of a triangle is 1/2 base times height. So I need to find the base first, okay? The base is going to need to be from J to H. So if we see J is at -2, 1, and -1, and H is at 3, -1, that means they are -2, so 2 steps from here, 3 steps here, so that's a total of 5 as the base. And then to find the height, we're just going to go from the top of the triangle and draw a straight line down to the base. This right here is at -1. G is at the height of 2. So the height is 1 plus 2. That'll be 3. So to find area, I'm going to do 1/2 base 5 times height 3. I know 5 times 3 is 15. Whoops. Whoa. Sorry about that. And I'm just taking 1/2 of that, which will be 7.5. So my answer for this one is 7.5 units squared. Let's maybe see if we can find the area of this one. Why don't you go ahead and give this one a try. Let's pause the video here. Try number 8 on your own, and when you're ready to check, click play. So the first thing we want to do is maybe think about where are these located on the coordinate plane. We have N at -1, 1. So I'm going to draw some dashes here. We're only up to 3, so I'm going to space this one out a little bit better. 1, 2, 3. Okay. N is -1, +1. So here's N. P is at 2, 1. Q is at 2, -2. And R is -1, -2. Okay. So we have all of our points ready to go. Let's find the area. Remember, to find the area of this shape, this is looking like a rectangle, we need to do a base times the height. So first we need to find the base, which could either be the bottom or the top. I'm going to start at the bottom though. R is here at -1, -2. Q is over here at 2, -2. So we just want to find the distance from R to Q. So this is -1. This is 1, 2. So the distance of RQ is equal to 3. So this is our base. Okay. The height we can say is from P to Q. So let's look at the height from P to Q. I know P is above 1 from the 0 x-axis, and then Q is down 2, so that's a total of, again, 3. So the height is also 3. So to find my area, I'm just multiplying these together, and I get 9 units squared. Okay. We've got one more to try. If you're willing to try it, this is how we do it. Go ahead and pause it, try it, and when you're done and ready, click play. All right, so I've gotten my points plotted, F, G, H, and J. I'm connecting my dots here, and we're just trying to find the area once more. So in order to find this area, I need to find the base and the height. So I'm going to find the length of J to H. H is approximately at 1, -1. J is at -2, -1. So that means JH is equal to 3 length. And then the height from G, let's do G to H. G looks like there's 1, 2, 3 units. H is another one, that's 4. So GH is a height of 4. So base times height, 3 times 4 to find my area will be 12 units squared. That's going to conclude our lesson for 1.4 today. Thanks so much for tuning in, and we'll catch you next time.